Hello, everyone. Welcome to today's lesson. Process flow diagrams are the common language of the chemical industry, and they are the core tool for chemical production, design, and management, with their application spanning the entire project lifecycle. Next, we begin learning Scenario 6 of the fundamentals of modern chemical industry, reading and drawing process flow diagrams. This lesson has two learning tasks. The first is to read, interpret the process flow diagram for AO/BO polyurethane adhesive production and waterborne polyurethane synthesis. The second is based on a brief description of the production process to draw the process flow diagram for the production of polyurethane elastomers and polyisocyanate. To complete these two learning tasks, we need to know the methods for reading and drawing process flow diagrams. Let's first discuss reading process flow diagrams. The content of a process flow diagram mainly includes the entire story of how raw materials are transformed into products, and its purpose in reading is mainly to understand three key aspects: an overview of the process, the main equipment and its functions, and the production steps through which materials pass. It is like when we travel to an unfamiliar city. We need to first learn which major attractions, equipment the city has, what fun features each attraction offers, its functions, and the route we should follow to tour them, the production steps, so that we can enjoy our visit both well and efficiently. Having understood the purpose of reading, we then look at the reading steps, which include understanding the names of raw materials and products, as well as their origins and destinations, identifying the main equipment and its functions, and finally, outlining the basic process flow to test whether you have understood thoroughly. We will now tackle the first learning task. This is the block diagram of the AO/BO polyurethane adhesive production process. Please read the diagram and fill in the reading results into the provided table. From the diagram, we can clearly read the information that the raw materials for this process are diols and diisocyanates, and the product is AO/BO polyurethane adhesive. The first step of the basic process is to reduce pressure and dehydrate the diol, removing the water to prepare for the subsequent reaction. The second step is to prepare the required amount of diisocyanate. The third step is to thoroughly mix these two raw materials in a reaction vessel, and finally, the reaction synthesizes AO/BO polyurethane adhesive. The entire process is like cooking, mixing and processing various ingredients in a specific sequence to ultimately produce a delicious dish. This is the process flow diagram for the waterborne polyurethane synthesis scheme. Please read the diagram and fill in the reading results into the table. From the diagram, we can see that the raw materials for this process are isocyanate and polyester polyol, and the product is waterborne polyurethane. The main equipment includes a prepolymer reactor, a reactor, and a post-reactor. The function of the prepolymer reactor is to stir the materials and carry out the prepolymerization reaction, like initially mixing ingredients to allow them a preliminary fusion. The reactor is used for carrying out a neutralization reaction. The post-reactor conducts a chain extension reaction, ultimately producing waterborne polyurethane. The basic process of synthesizing waterborne polyurethane is to first pump polyester, polyol, and isocyanate into the prepolymer reactor. According to the process ratio, and then activate the stirring device to mix the materials. Next, add additives and catalysts into the prepolymer. Carry out the prepolymerization reaction under atmospheric pressure, then add solvent and neutralizing agents into the reactor so that the prepolymer undergoes a neutralization reaction. Finally, in the post-reactor, add deionized water and emulsifiers, and at low temperature, the prepolymer undergoes dispersion, emulsification, and chain extension, resulting in the production of waterborne polyurethane. This process is like a relay race, with each piece of equipment playing a key role at different stages, all interconnected, ultimately yielding the product. The reading test challenge has been successfully completed. And next, we will learn how to draw process flow diagrams. First, we study the drawing of process block diagrams. The first step is drawing boxes, which should be drawn in order from left to right and top to bottom, using thin, solid lines to represent reaction unit operations, reaction processes, or workshops equipment, which is like drawing a small house for each small production step. The second step is to label each box with the corresponding unit, operation, reaction process, or workshop equipment, so that others can immediately know what each small house represents. The third step is to draw process flow line with arrows using thin solid lines between the boxes, with the arrow direction indicating the direction of material flow. The fourth step is to annotate the process flow lines with necessary text descriptions, such as the source of raw materials, destination of products, and material parameters. To deepen understanding, we will practice with the second learning task. Please draw a block diagram. Based on the production process flow of polyurethane in elastomers, please note that in the drawing of the block diagram, the labels within the boxes should indicate the unit operation, reaction process, or workshop equipment, and raw materials and products do not need to be written inside the boxes in this task. The boxes should be labeled with the unit operations or reaction processes. The reference answer is shown in the diagram. Did everyone successfully complete the challenge? Finally, let us learn how to draw process flow charts. In drawing a process flow chart, the following points must be noted. First, how to draw equipment. Equipment should be drawn in sequence, using thin, solid lines according to the process order, and the equipment schematic should be drawn in accordance with relevant standards. For example, in China, one may refer to the common equipment symbols in process flow diagrams as specified in the standard unified provisions for the content and depth of chemical process design and construction drawings HG/T20519.2 2009. The common methods for drawing equipment can be referred to in the diagram on the right. The relative vertical positions of the equipment and the locations of important connection ports on the equipment should roughly conform to reality. An identical equipment may be drawn only once. Process flow lines are divided into main process flow lines and auxiliary material flow lines, with the main process flow lines drawn using thick, solid lines, and the auxiliary material flow lines drawn using medium solid lines. The equipment labels should be listed on below, or near the diagram in prominent positions with the equipment numbers and names, which can be listed collectively by number, and the equipment names can also be directly labeled on the diagram. Next, Let us challenge ourselves with drawing a process flow chart. Please, based on a brief description of the polysol cyanate production process, draw the process flow chart for that process. We need to first draw a reaction kettle equipped with a stirring device, and then, according to the process flow description, depict the materials entering and exiting the reaction kettle with the equipment name labeled on the diagram. The reference answer is shown in the diagram. Did everyone successfully complete the challenge? Today, we have learned how to read and draw process flow diagrams, and we have understood the purpose and steps of reading process flow diagrams, as well as the steps and requirements for drawing them, thus successfully completing the learning tasks of reading and drawing. That concludes today's lesson. Process flow diagrams are the common language of the chemical industry, and mastering the skills of reading and drawing these diagrams is very important. And I hope you practice more after class to consolidate what you have learned through more practical examples, laying a solid foundation for your future studies and work.